All right, so chapter 1, we're going to get into talking about how we can change graphs based on like what happens to the equation. So every type of graph has a specific equation that's associated with it. So we have like linear graphs, which would just be ones that have straight lines. So we dealt with that in that review chapter, where you guys had to write equations in slope-intercept form. You graphed it using your y-intercept and your slope, and you guys had a straight line. Now, if that line gets moved, so if it's moved up, down, left, right, that's all called a transformation. So we're going to talk about not just like linear graphs, but also like quadratic graphs and cubic graphs and square root graphs, and how we can write stuff in their equation, in that equation of that graph, to actually read it and understand how it got changed. So we're going to first just kind of talk about these different types of transformations. So transformations is like the general idea of all of these different changes that can happen to a graph. So the definition says that it's a change in the position, the size of the shape of the figure. And so inside transformations, we have different types. So that's what I'm going to talk about with you guys in this first section. So the first one is called a translation. Okay, another word for translation would be slide. So it's when you've taken the graph and you move it. So it could be moving any direction, left, right, up, down. Depending on how it gets moved, will determine whether it was a horizontal translation or a vertical translation. So if you guys think about horizontal moves left, right. Think about like your horizon. Your horizon on the x-axis would be that line that goes left to right. The vertical, that would be going up and down. So that's your y-axis. So if you're moving it up on the y or down on the y. So these are like the two different types of translations that we can have. Now you'll have some graphs that actually do a combination, where it moves it to the left and it moves it up, or it goes to the right and it moves it down. So both of them can happen at the same time. So when we're reading through these, what they're going to do is give you guys like a coordinate, and they're going to tell you what's happening to it, like which direction is it moving. And so we have to then write the new coordinate. So we have to think about which coordinate got affected, the x or the y. And that's when you look at the keywords like right, left, up, down. So for this first example, it says we have the point 2, -1, and they want us to give the new coordinates if it moved 4 units to the left. So coming up here, right or left would be a horizontal translation. So if I'm moving this 4 to the left, since it's horizontal, that's my x-axis, it's going to affect the x coordinate. Okay, so 2, -1. I'm not going to do anything to that -1, so I'm just going to go ahead and leave that alone. Now the 2, that x, because I'm moving it to the left, if I think about going to the left on my graph would be going more negative. Because you start at 0, 0, and if you go to the left, you're going to the negative numbers. So instead of, I'm not going to add 4, I'm going to subtract 4 from 2. And that's going to move it to the left. That's going to shift that graph. So then to find the coordinate, you take 2 minus 4, which would be -2. And then you have -1. So this would be the new coordinate. Okay, so if we look at the second one, we're still starting with that coordinate 2, -1. This time it says we go 2 units to the right and 3 units up. So this has 2 different moves here. So remember, right would be affecting the x coordinate. Up, that goes back up to that vertical translation because that one's up or down. So that's going to affect your y coordinate. So we have 2 and we have -1. We're going to have to either add or subtract to both of these. 2 units to the right, that would be going towards the positive side. So you're going to add 2. And 3 units up, what do you guys think? If I'm going up, am I going to add 3 or subtract 3? Good, add 3. So we are going to have 2 plus 2, and then -1 plus 3. So that's going to be 4, 2. So to kind of summarize that, if you know that it's moving left or right, you affect the x coordinate. Up or down, you affect the y coordinate. If you're going to the left or if you're going down, that's when you have to subtract the numbers because you're going towards the negative side. Left is negative on the number line. Down would be negative on that y-axis. If you're going to the right, or if you're going up, you're going to add your number to your coordinate. Okay? The next type of transformation that we can have is called a reflection. Another word for reflection would be flip. So just like translation, we could also call that a slide. We could call reflection a flip because it actually takes the shape and it just flips it over this imaginary line that's on the graph, and that line is acting like the line of reflection. If you think about when you look in the mirror, you're reflected back, and everything's reflected backwards. So like if you have something written on your shirt, that reflects backwards in the mirror. Now the reflection is however close you're standing to the mirror, that's how close your reflection is going to be in the mirror to you. So if you back away from the mirror, your reflection gets smaller because the distance between you and the mirror is bigger. If you get really, really close to the mirror, your reflection gets bigger because the distance between you and the mirror got a lot smaller. So when you do a reflection, everything has to be exactly the same, but it's just going to be flipped over some line. Now the easy reflections is going over the y-axis and the x-axis. Whoops, so the y-axis changes just the x-coordinate. The x-axis changes the y-coordinate. When I say change, I mean it changes the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. So if you need to write yourself a note, change the sign. So for this first one, we have the point -4, 6, and we want to reflect over the x-axis. That means that we change the y-coordinate. So you're going to leave that -4 alone. Then you're going to change 6 to -6. So write down what you think your new coordinate should be for number 2. So if you reflect over the y-axis, what did you guys write down for your new coordinate? 4, 6. For that one, you just change the x coordinate. So that one should have just become +4. All right, at the bottom of this page, we see horizontal stretches and compression. So we've got some examples on the back side. But I want to talk about what the difference is between either a horizontal or a vertical stretch or compression. So stretch or compression. Stretching means that you're going to make this graph become like really tall and really skinny. So you're stretching it out upon the graph. Compression means that like you're pushing it down. You're causing it to grow at a lot slower of a rate. So those graphs tend to be very short but very wide. When you're doing a horizontal stretch or compression, it affects the x-coordinates. So if you're given a factor for that, you're going to multiply the x-coordinates by that. If it's a vertical stretch or compression, then you would multiply the y. So think about like horizontal again, that's your x-axis. So that's why we're affecting the x-coordinates. Vertical is your y because that goes up and down. So you affect your y-axis. So if we turn the page, we've got a couple examples here. They want us to perform the following compressions with the following points. They give us -1, 3, 0, 0, 3, 3. So part A wants us to do a horizontal stretch of 2. So horizontal stretch means that we're multiplying, if we come back up here to our rule, we multiply the x-coordinates by the factor. So for all of these 3 points here, we're going to take all the x-coordinates, so that -1, the 0, and the 3, we're going to multiply all of those numbers by 2. So I'm going to take -1 times 2. I'm not going to do anything to that 3, so I'm going to leave 3 alone. Then I'm going to take 0 times 2. Leave the second 0 alone. And then I'm going to take 3 times 2. Okay, so notice that all I did is I multiplied those x's by 2. That's what I have written there. So, final answer here then. For your first coordinate, it should say -2, 3. Second coordinate should still be 0, 0, because 0 times anything is just going to be 0. And then the last one would be 6, 3. So these are my new coordinates. Part B wants you to do a vertical compression of a third. So vertical compression up here says you multiply the y coordinates. So I want you guys to take a minute, multiply all of your y coordinates by 1/3. If you don't like multiplying by fractions, think of it as you're dividing by 3, if that helps you do the math a little bit faster. Okay, so for your first coordinate, you leave the -1 alone. 3 times a third, or 3 divided by 3, is going to be 1. So that first new coordinate should have been -1, 1. The second coordinate, you have 0, and then 0 times a third is just going to be 0. So again, that second coordinate doesn't change at all. And then the last one, 3, and then again 3 times a third is 1. So these should have been your new coordinates.